Hello students, let us discuss beta elimination, that is dehydrohalogenation in haloalkanes in the chapter haloalkanes and haloarenes. Please share, comment and like. Please subscribe to my channel. Dehydrohalogenation. What is dehydrohalogenation? Removal of hydrogen halide is dehydrohalogenation. So, alkyl halides, they undergo dehydrohalogenation minus HX, and of course we get alkene. For example, this is ethyl bromide. So this ethyl bromide undergo dehydrohalogenation, and here this is hydrogen halide, that is hydrogen bromide is removed, and we get C double bond C, H. So an alkene form, this is alkene, and of course this particular substance is ethylene. So when haloalkanes undergo dehydrohalogenation, we get product as alkene. With respect to a haloalkane, so here let us take CH3, CH2, CH2, CH2Br, and of course this is a carbon bearing halogen. So let us represent with a star mark. And the second carbon, the carbon which is connected to carbon bearing halogen atom, it is referred as beta carbon, whereas the first carbon is referred as alpha carbon. This is beta carbon, this is alpha carbon. And of course the next one, that is the carbon atom which is in third position from the halogen atom, this is gamma carbon. So this is alpha carbon, beta carbon, gamma carbon. Now when this haloalkane is heated in the presence of alcoholic KOH. What is alcoholic KOH? Alcohol, potassium hydroxide, is dissolved in ethyl alcohol, therefore this is alcoholic KOH. So when haloalkane is heated in the presence of alcoholic KOH, and here this bromine atom from alpha carbon and hydrogen from beta carbon, they are eliminated as hydrogen bromide, and of course we get as CH3, CH2, CH double bond CH2. This is right. Here hydrogen is removed from beta carbon, therefore this reaction is also referred as beta elimination. So dehydrohalogenation in haloalkanes takes place as beta elimination. What is beta elimination? Beta elimination is nothing but removal of bromine atom from alpha carbon and hydrogen from beta carbon as hydrogen bromide or hydrogen halide, and of course this elimination is referred as beta elimination. Now let us discuss the mechanism. What is mechanism? The detailed discussion of a reaction in two or more steps is mechanism. Mechanism of beta elimination or dehydrohalogenation. So here, what is the reagent here? Potassium hydroxide This is alcoholic potassium hydroxide. Alcoholic potassium hydroxide generates nucleophile. This is nucleophile. What is a nucleophile here? OH. The so generated nucleophile attacks haloalkane. So this is ethyl bromide, and of course in the presence of nucleophile, and here this bromide ion is removed. Therefore we get C what is this? This is carbocation. Right, this is step 1. This is step 1. In step 2, this is CH3 H. So here this hydrogen H plus is removed, and of course it attacks OH minus. Therefore we get alkene. And of course the hydrogen present on beta carbon and this OH, they combine and form as water. Right here, and of course Br minus also forms here. So this is the mechanism. Now let us look into this mechanism once again. Alcoholic potassium hydroxide generates nucleophile, that is hydroxyl nucleophile. In the presence of this hydroxyl nucleophile, the bromide ion removes, and of course we get ethyl carbocation. The ethyl carbocation, the OH group, OH nucleophile attacks the H plus ion present on beta carbon and forms as water, and finally we get alkene. Let us see one more example. Beta elimination from tertiary alkyl halide. CH3, this is CH3, this is Br. In the presence of alcoholic KOH, and you observe here carbon bearing halogen atom is referred as, this is alpha carbon. And what is the beta carbon? This carbon is adjacent to alpha carbon, therefore this is beta carbon, this is also beta carbon, this is also beta carbon. So in tertiary alkyl halide there are 3 beta carbons, right? Therefore hydrogen can be removed from any one of these beta carbons. So here we get bromine from alpha carbon and hydrogen from one of the beta carbons, it is removed, and we get C double bond CH2, and of course here this is methyl group. So this is alkene. What is the name of this substance? This is propene prop 1-ene. So double bond is present on first carbon. On second carbon methyl group is present. Therefore this is 2-methyl prop 1-ene. The product is 2-methyl prop 1-ene. So when tertiary butyl bromide is subjected to beta elimination, that is when it is heated in the presence of alcoholic KOH, we get the product as 2-methyl prop 1-ene. Let us see one more example of beta elimination. This is CH3, CH2, CH, and of course bromide. This is CH3. So what is this? Isobutyl bromide. Isobutyl bromide. Or what is the IUPAC name? 2-bromobutane. Now this is alpha carbon. To this alpha carbon, 2 more carbon atoms are attached. So the carbon attached to alpha carbon are referred as beta carbon. So this is one beta carbon, this is one beta carbon. Now in the presence of alcoholic KOH, now from which carbon hydrogen is removed? There is a possibility of removing hydrogen from both the carbon atoms. Suppose if the hydrogen is removed from the first carbon, then what is the product? CH3, CH2, CH, double bond CH2. What is this substance? 1-butene. 1-butene. Suppose if a hydrogen is removed from the third carbon, then what is the product? The product is CH3, CH, double bond CH, CH3. So what is this substance? But-2-ene, but-2-ene or 2-butene. So there is a possibility of formation of two products if bromine atom is present on middle of the carbon atom. Then in which case the percentage of a compound formation is more, whether 1-butene is more quantity or 2-butene is in more quantity. So this can be understood by a generalization, that is Say's-F rule. Say's-F rule. So what is Say's-F rule states? In case of haloalkane can eliminate hydrogen halide in two different ways. The preferred one is the one which is maximum alkylated. So in case of haloalkane, in case the haloalkane can eliminate hydrogen halide, that is HX, in two different ways. Two different ways we discussed here in the above example. The preferred one is the preferred alkane is the most alkylated. Most alkylated means with respect to double bond, the alkyl groups are maximum. So in case of 1-butene, with respect to double bond, there is one ethyl group on one side and no alkyl group on the other side. Whereas in case of but-2-ene, with respect to double bond, there is one methyl group on one side and another methyl group is on another side. So the but-2-ene is referred as more alkylated. So this is more alkylated. Therefore, this substance is major substance. This substance is a minor substance. Minor substance means the quantity of but-2-ene is large. It is nearly 80%. Whereas this substance is minor substance. Minor substance means the quantity formed is less. It is only 20%. So the generalization is Say's-F rule. Say's-F rule states that in case the haloalkane can eliminate hydrogen halide in two different ways, the preferred alkene is the most alkylated, which means the more number of alkyl groups attached to the doubly bonded carbon atom. Let us take one more example. CH3, CH2, CH2, CH, CH3. So halogen atom is here. So this is alpha carbon, this is beta, this is also beta. So here the substance is heated with alcoholic KOH. So as we discussed, there are two possibilities. The two substances are possible here. So if hydrogen is removed from first carbon, then what is the substance we get? CH3, CH2, CH2, CH, double bond CH2. So what is this substance? This substance is pent 1ene. What is the other substance? Suppose if the hydrogen atom is removed from, this is first carbon, second carbon and the third carbon. If hydrogen is removed from third carbon, then we get CH3, CH2, CH, double bond CH, CH3. So what is this substance? This substance is pent 2ene. Double bond is present on second carbon. Right. So out of these two, which is major substance, which is minor substance? This is minor substance. Minor substance or minor product, we can say minor product. And of course this is major product. Major product. Why it is major product? With respect to double bond, this is ethyl group and of course this is methyl group. So this is more alkylated. More alkylated. Since it is more alkylated, this is the preferred alkene. Whereas here in pent 1ene, with respect to double bond, there is alkyl group only on one side. So this is less alkylated, therefore this is a minor product and of course this is major product. Now let us discuss the reactivity. Reactivity of haloalkanes. Haloalkanes towards beta elimination. Beta elimination. Now let us see some substances. This is CH3, CH3, CH3. This is Br. What is this substance? This is tertiary butyl bromide. Tertiary butyl bromide. Now other substances CH3, CH2, CH, bromine, CH2. What is this substance? This substance is secondary butyl bromide. Secondary butyl bromide. What is tertiary? Tertiary means carbon bearing halogen atom. Carbon bearing halogen atom. This is the carbon bearing halogen atom and it is connected to 3 more carbon atoms. Therefore, it is tertiary butyl bromide. Secondary butyl bromide means carbon bearing. This is a carbon bearing bromine atom or bromide. It is connected to 2 more carbon atoms. Therefore, it is secondary butyl bromide. On the other hand, this is CH3, CH, CH2, Br. This is primary haloalkane. Primary haloalkane. Carbon bearing halogen atom is connected to only 1 carbon atom. So, in this case, when it is heated with alcoholic KOH, in the presence of alcoholic KOH, what do we get? CH3, C double bond, CH2, CH3. So here double bonded carbon atom is connected to 2 more carbon atoms. 2 more carbon atoms, that is 2 ethyl groups, this and this. On the other hand, when secondary butyl bromide is heated with alcoholic KOH, what do we get here? CH3, CH3, CH2, CH, double bond CH3. Here to this double bond only 1 alkyl group is connected. So this is less alkylated because only 1 alkyl group is present on doubly bonded carbon atom. This is more alkylated. More alkylated. The more alkylated alkene is more stable. So this is more stable. Now, so More alkylated alkene is more stable when compared to less alkylated alkene. So here this is less alkylated. On the other hand, when primary haloalkane is heated with alcoholic KOH, what do we get? This is CH2 double bond CH2. So this is least alkylated. Least alkylated. So out of these three products, what is the name of this substance? This is 2-methyl propionine. 2-methyl propionine. 2-methyl propionine is more alkylated. Therefore, this is formation of this alkene is forms quickly when compared to 1-butene and of course ethylene. Thus, we can confirm that the reactivity of haloalkanes towards elimination is tertiary alkyl halide is greater than secondary is greater than primary. Thus, the order of reactivity is tertiary alkyl halide is greater than secondary is greater than primary. Suppose if we among various alkyl halides, the reactivity is RI. RI means iodoalkanes. Iodoalkanes have greater reactivity than bromoalkanes, than chloroalkanes. So this is the reactivity of various alkyl halides is iodoalkane is greater than, bromoalkane is greater than chloroalkane. This is chloroalkane. Thank you.